Dear all, welcome back. Today we will discuss Woodward Fieser rules for calculating lambda max in alpha beta unsaturated carbonyl compounds. Alpha beta unsaturated carbonyl compounds. Right? See, these are the base values for different types of alpha beta unsaturated ketones or alpha beta unsaturated carbonyl compounds. For example, acyclic alpha beta unsaturated ketones will have a base value 215 nanometer. Acyclic alpha beta unsaturated ketones will have a base value 215 nanometer. While 6-membered cyclic alpha beta unsaturated ketones, 6-membered cyclic alpha beta unsaturated ketones will have a base value 215 nanometer. 215 nanometer, same as acyclic alpha beta unsaturated ketone. Whereas 5-membered cyclic alpha beta unsaturated ketones will have a lambda max 202 nanometer. That is, the base value for 5-membered cyclic alpha beta unsaturated ketones is 202 nanometer. While alpha beta unsaturated aldehyde will have a base value 207. Okay. Then if we look at the increment for each double bond extending conjugation, that is increment for each double bond extending conjugation, that is 30 nanometer. Increment for each of the double bond extending conjugation. For alkyl group or ring residue at the alpha position, it will be 10 nanometer. For beta alkyl group or ring residue, it will be 12 nanometer. 12 nanometer. Right? If alkyl group or ring residue is at the gamma and higher position, it will be 18 nanometer to be added as increment. Right? If there is hydroxy group at the alpha position, we have to add 35 nanometer. While hydroxy group at the beta position contribute 30 nanometer as the increment. If hydroxy group is at the delta position, then we will have to add 50 nanometer as the increment. Then see, acyloxy group at alpha, beta or delta position contribute 6 nanometer, while methoxy group at the alpha position contribute 35 nanometer. At the beta position, it will contribute 30 nanometer. At the gamma position, it is 70 nanometer, whereas delta position, it is 31 nanometer. This for the methoxy substituents. Then alkyl thio group if present at the beta position, we have to add 85 nanometer as the increment. While chlorine at the alpha position, we have to add 50 nanometer if it is at the beta position. That is, if chlorine is present at the beta position, we will have to add 12 nanometer as the increment. Then see, if it is bromine, that is at the alpha position, it contributes 25 nanometer as the increment. If bromine is at the beta position, we have to add 30 nanometer as the increment. See, dialkyl amine group, if it is present at the beta position, then we will have to add 5 nanometer as the 95 nanometer as the increment. Okay. While exocyclic carbon-carbon double bond contribute 5 nanometer, while homoannular diene component, if present, we will have to add 39 nanometer as the increment. Then this increment added with the base value, we will get lambda max, calculated lambda max in nanometer. Okay. See, the above calculation is based by taking ethyl alcohol as solvent or ethanol as solvent. If we change the solvent, then a solvent correction must be added. For example, ethanol 0 nanometer, methanol 0 nanometer. While dioxane, if we change the solvent from ethanol to dioxane, we have to add 5 nanometer. If it is chloroform, the solvent correction of 1 nanometer is to be added. If it is ether, a solvent correction of 7 nanometer is added. While hexane, it has to be added 11 nanometer. If we take cyclohexane as the solvent, we have to add 11 nanometer as the solvent correction. If it is water, we have to subtract 8 nanometer from the calculated value of lambda max. Okay. Now let us consider some of the important examples. For example, first mesotyl oxide. This compound is called mesotyl oxide. It is an acyclic alpha beta unsaturated ketone. Alpha beta unsaturated ketone, mesotyl oxide. Because it is acyclic alpha beta unsaturated ketone, it has the base value 215 nanometer. 215 nanometer. See, it is the alpha position, it is the beta position. You can see this beta position consists of 2 methyl groups or 2 alkyl groups as the substituent, and hence 2 beta alkyl substituent contribute a value of 2 into 12, that is 24 nanometer as the increment. Thus, the total value of lambda max or the lambda max calculated will be 239 nanometer for this molecule mesotyl oxide, right? Then see the next example. It is an alpha beta unsaturated ketone. Alpha beta unsaturated ketone or cyclic 6-membered ring. It is cyclic alpha beta unsaturated ketone. 6-membered cyclic alpha beta unsaturated ketone. Thus the base value will be 215 nanometer. 215 nanometer. See, it is the alpha position, it is the beta position. You can see this alpha position has a ring residue or an alpha alkyl substituent or ring residue, and this will contribute 10 nanometer as the increment. That is one alkyl substituent or one ring residue at the alpha position that will contribute 10 nanometer as the increment. See, this position is beta position. It has a ring residue or alkyl substituent at this position, beta position, and this will contribute 12 nanometer as the increment. That is one beta alkyl substituent. This substituent contribute 12 nanometer as the increment. See, the total value will be 237 nanometer. That is the calculated lambda max in ethanol will be 237 nanometer. That is in ethanol. But see, this question is to calculate lambda max in hexane. So you will have to add solvent correction. For hexane, it will be plus 11. That is 11 nanometer is to be added to the calculated lambda max value in ethanol. So that 237 plus 11 becomes 248 nanometers. So the lambda max in hexane will be 248 nanometer for this molecule, right? Then consider this molecule. It is a 5-membered cyclic alpha beta unsaturated ketone, 5-membered cyclic alpha beta unsaturated ketone. See, here it is the alpha position which consists of a hydroxy group as a substituent, and it is the beta position which has a ring residue. So one alpha hydroxy groups contribute 35 nanometer to the base value, or add up to the base value of 202 nanometer. That is the base value for alpha beta unsaturated cyclic 5-membered ring, alpha beta unsaturated ketone with a 5-membered cyclic or cyclic 5-membered alpha beta unsaturated ketone having base value 202. One hydroxy group at the alpha position contributes 35 nanometer. Here a ring residue or an alkyl substituent at the beta position which will contribute 12 nanometer. So the total value becomes 249 nanometer. That is the calculated lambda max value in ethanol will be 249 nanometer for this molecule, right? Then see this example. It is a 5-membered enone, 5-membered cyclic enone, cyclic 5-membered enone. It is the alpha position, it is the beta position. You can see this alpha position consists of a bromine atom, and this beta position consists of two ring residues. One is this residue and the other is this. Alpha bromine contribute 25 nanometer to the base value of 202 nanometer. That is the base value for 5-membered enone, cyclic enone, which has the base value 202. To this we have to add the contribution of bromine at the alpha position, that is 25 nanometer. Then you can see there are two beta alkyl residues or ring residues, and each of them contribute 12 nanometer. That is why 2 into 12, a total of 24 nanometer is to be added as the increment. And you can see this double bond which is projected outside this ring, and so this can be taken as the exocyclic double bond, and this will contribute a 5 nanometer as the increment. Thus the total lambda max value or the calculated lambda max value becomes 256 nanometer, 256 nanometer, right? See, it is another important example of alpha beta unsaturated ketone. It is cyclic alpha beta unsaturated ketone. So the base value will be 250 nanometer. See, it is alpha position, it is beta position, it is gamma position. This gamma position has a ring residue or an alkyl substituent at the gamma position, which will contribute 80 nanometer as the increment to the base value. That should be added to the base value. Okay, it is the gamma position. It is the delta position. You can see this position consists of two alkyl substituent or ring residue. One is this residue while the other is this residue, and so two alkyl residues or ring residues are present at the delta position. Okay, and so we have to add 2 into 18 nanometer, that is 36 nanometer for these two alkyl or ring residues. See, this double bond can be represented as the double bond extending conjugation. Double bond extending conjugation, because here is a single bond, it is a double bond. So conjugation takes place. So this double bond can be taken as double bond extending conjugation, which will contribute 30 nanometer. Another important thing is these two double bonds are present in the same ring, present in the same ring, and so it is a homoannular diene system. Homoannular diene system. And so for homoannular diene component, we have to add 39 nanometer as the increment. For homoannular diene, that is the double bond, two double bonds are inside one ring. And so we have to add 39 nanometer as the increment for homoannular diene component. Homoannular diene component. Thus, the total value of calculated lambda max or the calculated lambda max value will be 338 nanometer. 338 nanometer for this molecule. Okay. See, this is an alpha beta unsaturated ketone with a 6-membered cyclic system, or it is a 6-membered cyclic alpha beta unsaturated ketone, and hence will have a base value of 215 nanometer. 215 nanometer is the base value for this molecule. See, it is the alpha position, beta position, gamma position, and delta position. Here is a double bond extending conjugation. This double bond is a double bond which extend the conjugation, and hence will contribute 30 nanometer as the increment. The delta position, in the delta position there is a ring residue, and this ring residue at the delta position contribute 80 nanometer. Similarly, as in the previous example, these two double bonds are inside one ring, inside this ring, C. So it is a homoannular diene system. Homoannular diene system. Homoannular diene component usually contribute 39 nanometer as the increment. Thus, the total calculated lambda max will be 302 nanometer for this molecule. Right? It is another important molecule. It is an alpha beta unsaturated 6-membered cyclic alpha beta unsaturated ketone. But this molecule has the carbonyl group with 2 alpha beta unsaturation on either side. You can see it is the alpha beta unsaturation this side, and it is another alpha beta unsaturation on this side. That is alpha beta unsaturation on either side of this carbonyl group. That is, there is a cross or branched conjugation in this compound. In such cases, the lambda max is usually calculated by considering most highly substituted conjugated system, which gives higher value of lambda max. Here, if we consider these two unsaturation on either side, this beta position has one substituent. But in this case, the beta position has 2 alkyl substituents. One is this and another is this. So this will contribute maximum lambda max value or maximum lambda max value, and hence this has to be taken for consideration. Thus, the base value for this molecule will be 250 nanometer because it is a 6-membered cyclic alpha beta unsaturated ketone. We have to take this unsaturation as the as our system, because this beta position containing 2 alkyl residues. But in this case, this beta position has only 1 alkyl substitute. So it is our system. See, it is alpha position, it is beta position, this beta position having 2 alkyl substituents. So 2 beta ring residue contribute 2 into 12, total of 24 nanometer as the increment. See, this double bond is an exocyclic double bond, exocyclic carbon-carbon double bond with respect to this ring. It is projected outside this ring, so it is exocyclic double bond. This will contribute 5 nanometer as the increment. Thus, the total value or the calculated lambda max will be 244 nanometer for this molecule. Okay, it is another important example. It is an alpha beta unsaturated cyclopentanone system. Cyclopentanone system. That means a 5-membered cyclic alpha beta unsaturated system. So that the base value for this molecule will be 202 nanometer. You can see it is the alpha position, it is the beta position. This beta position has an alkyl substituent, and this alkyl substituent at the beta position contribute 12 nanometer as the increment. That is one beta alkyl substituent, 12 nanometer as the increment. See, it is the beta position, it is the gamma position, where there is an extending conjugation, a double bond extending conjugation is here, and this will contribute 30 nanometer as the increment for one double bond extending conjugation. That is at the gamma position. See, this double bond is also an exocyclic double bond with respect to this ring. It is projected outside this ring, and hence it is an exocyclic double bond. So it will contribute a 5 nanometer as the increment. See, it is alpha, beta, gamma, and it is delta position. This delta position has a ring residue. Here is a ring residue at the delta position of the molecule. This delta ring residue contribute another 18 nanometer. Another 18 nanometer as the increment. Okay, it is alpha position, it is beta position, beta alkyl substituent contribute 12 nanometer. Here is the double bond extending conjugation that will contribute 30 nanometer. It is an exocyclic double bond that will contribute 5 nanometer. See, beta gamma ring residue that will contribute 18 nanometer. Here this position is delta position. There is a ring residue that will contribute another 18 nanometer. Thus, the total calculated lambda max will be 285 nanometer for this molecule. Okay. Then see this example. It is a 6-membered alpha beta unsaturated ketone system or enone system. This is the alpha position, it is the beta position, gamma and delta. So, because it is a 6-membered enone, the base value will be 215 nanometer. You can see there is a double bond extending conjugation. Here is the double bond extending conjugation, double bond, single bond, double bond. Here it is a double bond which extend the conjugation, and this will contribute 30 nanometer as the increment. Okay. Then this position is beta. There is a beta ring residue, beta alkyl substituent or beta ring residue. This beta ring residue contributes 12 nanometer as the increment. Then see, this is the gamma position, it is the delta position. This delta position has a ring residue that will contribute 18 nanometer as the increment. Right? Then see this double bond which project outside this ring, and so it is a exocyclic double bond with respect to this ring. So that this double bond, the exocyclic double bond, contribute 5 nanometer as the increment. Thus, the total calculated lambda max of this molecule becomes 280 nanometer. Right? See, it is another important example. It is an alpha beta unsaturated aldehyde system. Alpha beta unsaturated aldehyde system. It is 6-membered cyclic alpha beta unsaturated aldehyde. Okay. For alpha beta unsaturated aldehyde system, the base value will be 207 nanometer. 207 nanometer. See, a double bond, single bond, double bond. So this double bond is a double bond extending conjugation. This double bond extends the conjugation of this molecule, and so it is a double bond extending conjugation. This will contribute 30 nanometer as the increment. This double bond extending conjugation will contribute 30 nanometer as the increment. Okay. See, it is the alpha position, and this alpha position, it is the alpha position, and so this alpha position having a ring residue. Here it is a ring residue which will contribute 10 nanometer. Okay, and it is the beta position, and here is another ring residue that will contribute 12 nanometer. Right? It is alpha, it is beta, it is gamma, and this gamma position has a ring residue here, and this ring residue will contribute 18 nanometer. Okay. Then it is delta position, that is alpha, beta, gamma, delta. This delta position having an alkyl substituent and also a ring residue, and this alkyl substituent at the delta position contribute 18 nanometer, and delta ring residue, this delta ring residue also contribute 18 nanometer as the increment. Then see, this double bond is exocyclic with respect to this ring, because this double bond projecting outside this ring, so that this double bond is exocyclic with respect to ring. See, this double bond which will be exocyclic with respect to this ring. So there are two exocyclic double bond. Two exocyclic double bond. One is projected here, another is projected from here. So two exocyclic double bond, carbon-carbon exocyclic double bond contributes 2 into 5, 10 nanometer. Thus the total or the calculated lambda max value for this molecule will be 323 nanometer. Right? Okay, it is the last example in this video. It is an alpha beta unsaturated 6-membered cyclic enol. Thus the base value will be 215 nanometer. 215 nanometer. Here you can see a double bond extending conjugation, that is double bond, single bond, double bond. This double bond is considered as a double bond extending conjugation, which will contribute 30 nanometer as the increment. Right? Then see, it is the alpha position. Here is a ring residue here. Here is the ring residue. This is the ring residue, alpha ring residue. This alpha ring residue contribute 10 nanometer as the increment. Then it is the beta position, it is the gamma position. This gamma position has a methyl substituent, that is gamma alkyl substituent, which will contribute 18 nanometer. Gamma alkyl substituent contribute 18 nanometer as the increment. Then it is the delta position. You can see two alkyl substituent or ring residue in the delta position. One is this, and another is this alkyl residue. So two alkyl residues are present at the delta position, which will contribute 2 into 18 nanometer, that is 36 nanometer as the increment. Then you can see it is the exocyclic double bond with respect to this ring, and it is another exocyclic double bond with respect to this ring. So two exocyclic double bond, carbon-carbon double bond, which will contribute 2 into 5, that is 10 nanometer. Hence the total lambda max or the calculated lambda max will be 319 nanometer. Right? Okay, with this example, I conclude my session here. Thank you for listening. Thank you.